So let's go over a stereochemistry problem with R and S. So R and S are two abbreviations to review the orientation of the molecule, what stereoisomer it is. So a R, this is a bad pen, an R conformation is clockwise. So R is clockwise or to the right, and S is counterclockwise or to the left. So the key is really to remember R. If you know R, you're good to go. R to the right, clockwise. All of those go together. So let's use this as our example. S3-chlorohexane. So first we know it is hexane, so there should be 6 carbons. So that's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And at position 3, we found our chiral center. So R and S can only be done around chiral centers, and a chiral center is where all 4 substituents on carbon are different. So A, B, C, D, they're all different. We have chlorohexane. So let's just put it in there as our baseline, and this may or may not be right. So this would be it, and whether or not this hydrogen or this chlorine are into or out of the page will determine whether we're S or R, but we can switch them if we need to later. So what you do is you number the groups in order of their placement on the periodic table. So if your periodic table in general looks like this, the more that way you go up and to the right, the higher priority it is. So for this molecule, we go out, if this is our chiral center right here, we go out one step. We got chlorine, hydrogen, carbon, and carbon. So this be priority 1. Next, we have carbon, carbon, hydrogen. So hydrogen's over here, it's going to be a bottom priority, chlorine's over here, carbon's right here. So we know that we can continue either between carbon 2 or carbon 4. So they're the same, right? They're both CH2, so they must be equal, but we have to pick one. So if we go one more, we get CH3. We go one more, we get CH2. Well, that's carbon, carbon, hydrogen. This is going to be carbon, carbon, carbon. So this side will be priority group 2, leaving this to be priority group 3. And if you have a solo hydrogen, it's always going to be priority group 4. Now, from here we want to go in order from 1, 2 to 3 to find our stereochemistry. So we would go for this one with, now this is actually a key too, is you want hydrogen, you want number 4, if you have hydrogen, always back. If you push it back, it means you can just go in a circle. So we know that that's back into the page. This one is coming out towards us. So our arrow would be counterclockwise, which would make this S3 chlorohexane. So that is our first example problem. Hopefully it makes sense. This is called the absolute configuration, or I think in some places it's Chan-Ingold or something like that, but R and S is a lot easier. The next thing I'd like to go over just real quick is a couple rules. So the first two rules were already covered. It's that R is to the right, clockwise, S is to the left, counterclockwise. This one was already covered, that it has to be at a chiral center. So that means if you have carbon, every substituent is different. Also, we like to have hydrogen in position 4 and out of the page. Next, you're going to order, or let's just say number your groups based on the periodic table. So it helps to keep it, you're going to need to keep it somewhat in the back of your mind, or if you get a copy of the periodic table, I guess it's a little bit easier. But normally it's like the bigger the group, the more up to the right that your group is, that your next adjacent atom is, the higher priority it gets. The biggest thing to recognize is that when you reach something that is the same, so if these are both carbons, you need to go on to the next one. So this kind of just gets ignored. Oh, okay, carbon higher than hydrogen. That's kind of the easiest way to do it. So if you're still watching, and I know I'm rambling at this point, let's do one more example. So if I was going, let's do this one the opposite way too. Let's start with a molecule and let's name it. The first step to any of these example problems is going to be, well, let's find the chiral center. This is 2 hydrogens, so that's not it. This is a double bond here, so that's it, not it. So this must be our chiral center. So let's redraw this a little. And let's put our OH group out of the page and our hydrogen into the page, just because we like that, that's easier. Then let's start numbering our groups. So first, boom, let's bump out one step, bump to here, carbon, oxygen, hydrogen, carbon. So we know that this is group 4 and this is going to be group 1 because oxygen is takes the biggest priority. It's it has the highest atomic number. Oxygen's atomic number is 8, carbon's atomic number is 6, right? So from there, we're going to go carbon, carbon, so that it doesn't really help us. We have to go one more step out. If we go one step here, carbon, we go one more step, we get oxygen. We go one more step, we get oxygen. Now we've got a little bit of a discrepancy here because, right, they're both going to oxygens are almost the same, where this one has carbon, oxygen, and then hydrogen, hydrogen. This one just has hydrogen, oxygen. Oxygen is one way to say it, that this would be 2 separate oxygens, which gives this group a higher priority. So this becomes priority 2, and this over here becomes priority 3. So I know that that is a little bit complicated, but the gist is that the larger atomic number, the more bonds to that, it's going to have a higher priority. Double bonds are going to have a higher priority than a single bond, given that they're the same molecule or same atoms. So now that we have this, we got to think, okay, hydrogen is into the page, that's good, so we can just pretend like it's back there, it doesn't count. And we want to count, or we want to go in an arrow, draw an arrow from 1 to 2 to 3. So we know that we're going clockwise, so that's to the right, so this must be R. And in case you're wondering, this is R glyceraldehyde. Little functional group review here too. We've got a alcohol group or hydroxide, another one here, and then an aldehyde group here, which is why this is named an aldehyde, because that's the highest priority functional group. Thanks for watching. Rover Star, Little Science Show. Have a good night.